In this section, we're going to be talking about the average value of continuous functions on closed intervals. By definition, the average value, or sometimes it's called the mean value, of a continuous function f of x on a closed interval ab is given by 1 over b minus a times the integral from a to b of the function. So now let's look at an example. Suppose we want to find the average value of the function negative 2x e to the minus x squared on the interval 0 to 7. So from our definition, our average value is going to equal 1 over 7 minus 0 times the integral from 0 to 7 of minus 2x e to the minus x squared dx. So in order to find the average value, we're actually going to have to solve this integral. So let's go over to the side here and look at just the integral of minus 2x e to the minus x squared dx. So we see that we're going to need a u substitution here. If we let u equal minus x squared, then du will equal minus 2x dx. So this integral now becomes the integral of e to the u, and what we have remaining after the substitution is minus 2x dx, which is actually identical to du. So this is the same as integrating e to the u du, which is just e to the u plus some constant of integration.
Don't get constant because we'll be doing a definite, so you can say that we avoid constant.
Which is just e to the u, and we're not going to add a constant of integration here because we're going to go back to our definite integral. So making our back substitution, instead of u here, we'll write minus x squared. So now we will have 1/7 times, having done our integral, e to the minus x squared, evaluated between 0 and 7. So now, let's use the fundamental theorem of calculus, part 2, to evaluate this. So first we'll put in 7 for x, we'll have e to the minus 7 squared, and then minus from our fundamental theorem of calculus, and then we'll put in 0, so we'll have e to the 0, which is 1/7 times e to the negative 49th minus 1. So this right here is the exact average value of the function minus 2x e to the minus x squared on the interval from 0 to 7. For a second example, let's find the average value of the function f of x equals cosine of 9x on the interval 0 to pi over 3. So using our definition of average value, it will equal 1 over pi over 3 minus 0 times the integral from 0 to pi over 3 of the function here cosine of 9x. So now we're going to need to integrate cosine of 9x dx. Well, instead of doing an explicit u substitution, simply remember that the integral of cosine of ax dx, where a is some number, is equal to sine of ax over a. So now, then, this integral becomes 1 over pi over 3 times sine of 9x over 9, evaluated from 0 to pi over 3. So now rewriting this and simplifying a little, the 1 over pi over 3 will be 3 over pi, and we'll have that 1/9, and then we'll have, applying the fundamental theorem of calculus, sine of 9 times pi over 3 minus sine of 0. And now the constant out front will just be 1 over 3 pi And both of these, sine of 3 pi and sine of 0, are both 0. So it'll be times 0, which is 0. So notice in this case that our average value is actually 0. So if we were to graph this function on that interval in our calculators, making sure that we have it in radians mode, we would get something that looks like this. Notice that the area above and below the x-axis cancels out here. So this area here would cancel out with this area here, and this area here would cancel out with this area here, giving us an average value of 0.